Okay, so here we have a question asking us to calculate the interquartile range and a percentile. And we're then asked to use those to decide whether there could possibly be any outliers in this data. Okay, so firstly, we have a cumulative frequency table with grouped intervals. The very first thing I need to check is whether or not I need to close the gaps. Do I need to use bounds on the end of each interval and the beginning of each interval? Since the first group ends in a 5 and the next one starts with a 5, I do not need to apply bounds, but you should always check to make sure you're working with the table correctly. If I'm going to make use of interpolation, I do need to work with cumulative frequencies. Now, I just like to make some space here and add the cumulative frequencies next to the frequencies. The first statistic I'm going to find is the lower quartile. We call this Q1. The lower quartile, its position is going to be 1/4 of the way through the data. So I can take the n value, divide it by 4. In this question, n is 34. So 34 divided by 4 tells me I should be looking for the 8.5th piece of data, the 8.5th value. Which group is it in? It's here, in between 6 and 7. I know because the group 6 to 7 ended on the 11th value, but started on the 7th value. So the 8.5th must be in that group. I'm going to use that to set up an interpolation diagram. So the 8.5th, the 7th, and the 11th. The 7th value, the start of this interval, was a 6. The 11th value, the end of this interval, was a 7. This is my diagram. Now we're going to make use of proportion to construct a fraction equation. Now I know numerically the length of the thick line, the distance between or the difference between the values at the end of the thick line, Q1 and 6, as a fraction of the difference between the entire line, 7 to 6, is going to be equivalent whether I'm using the x values or I'm using the cumulative frequencies. So I can say Q1 minus 6 over 7 minus 6 is exactly the same as 8.5 minus 7 over 11 minus 7. The numerators are both the length of the thick line and the denominators are both the length of the entire line. Okay, so some sensible rearranging. I've just simplified the numerators and denominators where I could, and then this can go into my calculator and I get a value of Q1. Q1 in this question, 6.375. That's the lower quartile. There's 1/4 of the data below 6.375. Okay, how about the upper quartile? In a similar way, I'm going to find its position. This time it's 3 times n over 4. So that's 3 times 34 over 4. I know 34 over 4 is 8.5. Multiply that by 3 to get 25.5. The 25th position. Okay, I can make another diagram. Which interval is this going to be in? The first cumulative frequency that went above 25.5 is down here, corresponding to the group 9 to 11. I know that the group 9 to 11 started on the 19th value, it ended on the 34th value, and it goes from 9 to 11. Once again, I've got my diagram ready. I'm going to do exactly the same technique to set up my fraction equation, and then I'm going to rearrange to solve for the upper quartile, Q3. Q3 is the upper quartile. There's 75%, 3/4 of the data below there. Rearranging, we get 2 times 6.5 over 15, add on the 9, and we get 9.867. That's the upper quartile. All right, brilliant. I have the 2 quartiles. The difference between these is known as the interquartile range. It's a measure of range that is not affected by any outliers. Q3 minus Q1. These 2 values I've just found, the difference between them is 3.49. Okay, 3.49 is our interquartile range. Okay, we'll save that for later. That's an important value, but we'll save that for later. Okay, moving on. We've also been asked to find the 19th percentile. Okay, the 19th percentile's position is going to be 0.19 times n. So 19% of n. 19 over 100 times n. And that ends up being the 6.46th value. Okay, exactly the same technique as we've been using. We need to decide which group it's in, we make an interpolation diagram, and then we make our fraction equation. Okay, 6.4 sixth value, that must be in this second interval, 5 to 6. It started on the sixth value, it ended on the seventh value, and we can put those numbers in. Okay, so P19 subtract 5 over 6 subtract 5 equals 6.49 minus 6 over 7 subtract 6. Sensible rearranging, again, we're getting very used to this technique, to this approach. Sensible rearranging gives us a 19th percentile of 5.46. If we ask for that percentile, 5.46. Okay, back to the question. We were told to try and determine whether there is any possible outliers in our data. Well, we first need to calculate our outlier boundaries. And to do that, we need to have the quartiles and the interquartile range. The lower outlier boundary can be found by starting with your lower quartile, Q1, and subtracting 1.5 times the interquartile range. In this case, it's 6.375, subtract 1.5 times 3.49. 1.14. That is my lower outlier boundary. If there are any values in this dataset, in this table, which are smaller than 1.14, they would be considered an outlier. Now, going back to the table, the smallest possible value was actually 3. So that means there cannot be any data values smaller than 1.14. There are no outliers at the bottom end of this data. Let's do a similar check at the top. The upper outlier boundary. This time start with the upper quartile and we'll add 1.5 times the interquartile range. The upper outlier boundary is 15.105. The largest value that this table represented was 11. So once again, there are no outliers at the top end of this data. It would need to be bigger than 15.1 to be considered an outlier. There are no values bigger than 15.1 in this data. So actually, there are no outliers. We've done the check and it's necessary to show that we've done the check, but our conclusion is that there are no outliers at the top end and then there are no outliers at the bottom end of this data. So we've done our checks, we've found our quartiles, we've found our interquartile range, and we've made a conclusion, we've made a deduction about whether or not there are any outliers in this data.